Hi, today we're with María Óskarsdóttir from Reykjavik, Iceland, and we're going to talk a little bit about credit scoring and some alternative data methods that can be used. Hi, Maria. Thanks for speaking with us. Can you tell us a little bit more about your background and what you do that lists credit scores?
Yeah, hi, thanks so much for having me for this interview. Yeah, so my background is in, well, mathematics, and then I did my PhD in business economics, more specifically like data science at KU Leuven in Belgium. And during my PhD, I was researching how you can use social networks for alternative information in predictive models, where I focused on both churn prediction, but also credit scoring. So we were kind of using the same methods in two different domains. And then I followed up on this research, applying similar techniques in insurance to detect fraud. That was during my postdoc, also in Belgium. But then, yeah, 2.5 years ago, I moved back to Iceland, where I'm now an assistant professor at Reykjavik University. And my focus continues to be, using alternative data and network methods to enhance, predictive models, basically.
Wow, thanks. That's really cool. In your credit scoring research, you've written a paper that we've talked to some of your colleagues about, called "The Value of Big Data for Credit Scoring: Enhanced Financial Inclusion with Mobile Phone Data." Could you explain a little more about what the implications of this paper are, like the focus on alternative credit scoring, and what is so important about this paper?
Yeah, well, it is like a worldwide problem that there are so many people that don't have access to regular bank instruments, just like checking accounts, saving accounts, and also credits. And that's because you have people living in rural areas. You have this like huge gender imbalance in many places, and just poverty and all kinds of issues. Like in many countries that don't have official IDs, for example. And that's where fintech or financial technology can really help include all this these people that are excluded. And like the World Bank and G20, they are kind of on a mission to enhance financial inclusion and using fintech. And that's kind of where our research comes in, because traditionally credit scores are based on your backing information. But if you don't have any backing information, there's no way to evaluate your creditworthiness. So what we did in this paper, which is kind of like a proof of work, we are not saying that this is how you should do it. It's more like this works to do it this way. We used what we called alternative data, so not the traditional data, to try to predict credit scores. And this alternative data that we used was data that is called call detail records, which is simply a list of all the phone calls that you make and receive, like who made the call, who received the call, and when the call was made and how long it lasted. And from this data, we created all kinds of variables describing the person's own calling behavior. So like timing of phone calls, was it in the morning or in the evening? Was it in the weekend or during the working days? Calling intensity, how often were people calling? And calling diversity, so how many different people were you calling? So these are like features that describe the person's own behavior, but then we also built like a social network where we could identify in this network like people that were in arrears, so they hadn't paid their loans, and we could from this network extract what we call network influence, so to see how many people you were connected to that were paying on their loans and were not paying on their loans, and that in that way we could kind of extract default influence variables. Those turned out to be less important. It was the most important group of variables were the person's own behavior, which was a really interesting result because it doesn't, well, they are equivalent to the banking information. Like the banking information tells you your own repayment behavior, right? And in a similar way, your own calling behavior tells something about your character too. So it was a really interesting result that we got there. Of course, we were using, so it was not a traditional credit scoring data set. This was for credit cards. So they are a bit different than like when you're asking for loans. But still, we managed to get to this interesting conclusion.
Wow, that's so interesting. Were there any like clear trends, like if you call more people, you're a better lender or something? Or do you remember anything like that?
Yeah, so we did not dig into the models themselves, and there was a reason for that. Because like we would always get this question that, okay, then I just change my behavior and just call, you know, only in the mornings and things like that. The goal is not to game this model, right? It's more like a proof of concept. So we didn't really want to dig into the variables, like the weights on the models. And in addition, we used random forest, which is a black box model. So you can't really explain how the prediction is made. We can see which variables were most important. And I don't remember exactly which ones were. It's in the paper, I believe. But we intentionally did not want to make statements like that. You should call 3 people on Mondays in the morning, like, because that's was not the goal, and that would never work in reality either.
Yeah, that's interesting. That brings up another question of, do you think there's any like negative ways that data like this could be used? Like what kind of problems were you trying to protect against in the way that you used your data?
Yeah, I mean, there's like all the ethical implications, right? Should you deny a person a loan just because they call, you know, in the afternoon? Then you're kind of digging into people's personal space, and that's not really good. So what we tried to emphasize in paper was to use this as positive information. So whenever you don't have the traditional data, then you could use the alternative data. And of course, you could use other kinds of alternative data. It doesn't have to be calling data. It was just like a proof of concept that you can do it like this. And for example, for me, like, I mean, I was living abroad for many years, and then I moved back to Iceland. And then here, I don't have a credit history. So when I want to come here and buy a house, it's very difficult to get a loan, right? Because I don't have a credit score. So this is like the situation where you could use this kind of approach.
Yeah, that's very interesting. Another question that relates to you specifically, why did you decide or to research alternative credit scoring, and why did you decide to do this kind of research?
Well, I was really like invested in this social network aspect. And at first in my during the research in my PhD, I was focusing on credit scoring. And it was kind of a coincidence that I got into this project specifically. We had this collaboration with a company that had lots and lots of data, and they had this project open. And I needed a new project for my PhD, so I kind of just went into it, like from the network perspective. So my goal was to use like the expertise that I had been building up in my previous research to use it in this new domain, right? So my background is more in like the network science and the social networks and less in credit scoring. But of course, I was really lucky to be being supervised by Bart Basins, who is like one of the pioneers in this field, and also Christian Bravo, who is like a big expert in credit scoring. And we kind of just combined our expertise into this project. But my main contribution was the networks.
It's really cool that you guys came from different disciplines and found a way to make something meaningful out of it. Let's see. Yeah. Oh, yeah. In my group's research, we found that credit scores can function as barriers to entry to the financial system. Like you said, with somebody with very little credit score needs the opportunity to build credit. Do you think that having alternative ways of building credit, how does this potentially make credit scoring more equitable for different people?
I think, like always in any analytics application, if you bring in different kinds of data, they all tell a different story. So, and also in credit scoring, if you bring in different data, you get like different sides of the person, right? And thereby you can get better models to predict credit scores. It's not useful to always bring in more of the same data, but you want the other type of data, because that's where you can get like really the performance boost. And this has been shown in I think many papers, and there's one book that I read recently. It's called Everybody Lies, and there, like the main point always is that the author, he was bringing together data from different sources, and thereby he could discover new things.
Wow.
So that's what the alternative data brings, right? That's this new side of the coin.
That's awesome. And then since you're in Iceland right now, and you also lived in Belgium, so you've seen some different systems. Could you tell us a little bit about what credit scoring looks like in Iceland, and how, or if it's different from other systems you've seen?
Yeah, I mean, I don't have a lot of experience, but basically, I mean, if you have an income, you can get a loan, or you have to have an income for like, I don't know, it's like a couple of years, or maybe just 1 year. And if you have an Icelandic income for more than a year, you are you can apply for a loan, because that's when you have built up enough credit history with the bank, right? And yeah, I think like it's not so difficult, but at the moment our housing market is kind of a mess. So I don't know how it is at this moment right now, but it's not difficult to get credit, let's say.
That's cool to hear about. Yeah. I guess just I'm personally interested in like these models, these social network models that you build. Could you tell us a little bit more about like how the models work? Like what kind of algorithms are you using, or data structures and stuff like that?
Yeah, so what we mostly do in this paper, for example, and my previous research, is that like you build a network, you connect the people together. And in this case, we used these call detail records to just connect to people that had shared a phone call. And then in this network, we had, because we had two data sets, we had the bank data set and the mobile phone data set. There were people in this network that were not customers of the bank, so only customers of the telco. And then we could, so they had kind of different labels. So there were people that were only customers of the telco. There were the customers of the bank, and then we categorized them as people in paying arrays and not, and then like the people that we were focusing on in the model. And what we did that we kind of extracted variables about the individual from this network. So it's called featureization, when you extract features from this network or anything else. And then for each individual, we are, for example, counting how many neighbors they have. So how many people do they call? That's called the degree of a node, basically how many edges it has, how many other nodes it's connected to. So that's like one variable. And then we count how many of the neighbors have defaulted, how many of neighbors have not defaulted. And then we also look into the second order neighborhood, so like the friends of the friend. We look at like triangles. That's like when like I'm friends with you and your sister, and you're also friends, then we form a triangle. And this is something that like Facebook uses a lot when it's recommending new connections. It finds like a common connection and then says, hey, you should be friends with this person. So you're counting like the number of these triangles in the network. So how many triangles am I a part of? That's a measure of how connected the network is, or how connected I am in the network. And then we use these propagation algorithms where we start from the bad nodes in the network, such as the defaulters or fraudsters, in the terms of when we are working in a fraud network. And we kind of propagate the bad influence from these people. And then every node in the network gets a score, which is kind of like an exposure to the bad influence. And then this score is one of the features we extract from the network. And to propagate this influence, we used in this paper both personalized PageRank and spreading activation, I believe. So those were the two methods that we used to spread this. And this is just an algorithm that kind of takes into account the entire network. So like starting with like the node itself, part of the influence is spread to all the neighbors, and part of the influence remains with the node. And then it's just like a for loop that runs 1,000 times or something until there's no change in the score anymore. So then the algorithm stabilizes, and then we use this score that every node receives as a variable. And we also calculate like the average score of all the neighbors, or the maximum score of the neighbors, or the minimum score, to see how distributed this score is in your neighborhood. So if you have like one neighbor that is really bad influence, or most of your neighborhood is low influence, for example. So that's kind of the exposure to this influence. And then these features that we take from the network, we combine them with the traditional variables about credit scoring. And then we just build like a predictive model using logistic regression or random forests or whatever we want. So that's mostly the method that we were using.
Wow, thanks for the thorough explanation. That was really interesting. Yeah, and I guess coming back to like the implications of these models, we already talked about how like there could be ethical issues with the data. And do you think there could be, I guess my group is looking into at this point more like what policy things can be done about credit scores, do you think it's important to have policy people working with scientists like you and your teammates when they make their credit score models? And like, how do you think that they can take these ethical issues and put them in policy decisions?
Yeah, I actually think that is really important, and that you should always keep in mind that the score that the model gives you should always be like reviewed by a person before a decision is made, right? You should never just say, no, the computer says no, you don't get the loan. There should always be a person that looks at what the computer says and then says yes or no. And then you could also, of course, bring in the policymakers to kind of tweak the models or make some rules or regulation about what can and can't be done. For example, using this alternative information in a negative sense. So if that brings down your score, then you should not use it, only if it increases your score. So that could be like one policy that you could decide on. But always having a human making the decision and not the computer. I think that's the most important part.
That's a really good point. It's like the garbage in, garbage out thing.
Yeah.
Yeah.
Exactly, and like that's what you've seen in like all these bad examples where machine learning and AI has been trained to make decisions, like in the criminal system in Florida, right, where you had this really bad consequences of a bad model, right? Mm-hmm. It's really important that you have a human, especially when you're making decisions about people's lives. There should be a human reviewing the outputs always.
Awesome. Thanks, Maria. That's really awesome stuff to hear about. Is there anything else you want to say before we wrap up here?
No, nothing that comes to mind.
Cool. Well, thank you so much for speaking with us.
My pleasure.
I'll stop the recording.